We've spent quite some time talking about the median, and we talked about the mode a little, and we will indeed study unimodal distributions. But some of you must be thinking by now that the most commonly used measure of location is one we haven't talked about at all, and that's the average. You go to a class, you take an exam, you come back after the exam, and you ask your teacher, what was the average? Why do you ask that question? We should examine that average and figure out whether that's a good question to ask. Now, how to calculate the average is no big deal. To find the average, you add up all the numbers that you have and you divide by how many numbers you have. I should point out that the average is also known as the mean. I will mostly use the term average, but I will use the mean when it's convenient, and you can use whichever one you want. So, simple example of a list. The list is 2, 4, 5, 9, and 10. 5 entries there. To find the average, you add up all of these, and you get 30, and then you divide the 30 by 5. That's how many entries you have, and your average is 6. This you've known how to do for a while, I think, most of you. Just to be sure that there are no misunderstandings, zeros do matter. If you throw in a 0 as another entry, then your list becomes 2, 4, 5, 9, 10, which was the old list, and another 0, so now it has 6 entries. The sum in the numerator is the same because you haven't changed the sum by adding a 0, but the denominator, the number of entries, has changed. And so the average drops to 5. And while we're about it, we should take a look at units of measurement. If these happened to be lengths in inches, then the total would be a length in inches and divide by 6, and you'd get 5 inches. So the units of the average are the same as the units of the list. So far, so good. And next, however, I am going to go through an exercise that is relentlessly negative. No, 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 and no. And that's a depressing thing to do, but really it's a great idea to get rid of any possible misconceptions early on. And so let's start by taking a look at this simple little list. 3, 8, 9, and 10, just 4 entries in the list. Its average is 7.5. And already by looking at that, you can tell one thing, which is that it is not true that half of the list is below average. The average is 7.5. It's right here, in between the 3 and the 8. Only the 3 is below average. So only 1 in 4 of these entries are below average. So it is not true in general that half of a list has to be below average and half has to be above. And so if you want to say it formally, the average and the median are different. The median is indeed the halfway point of the list, but the average need not be. One other thing. Do you see a 7.5 on this list? I don't. So it's worth noting that the average does not have to be one of the entries on the list. For many, many lists, you might have no entry that's equal to the average, and this is one of them. And the next thing I want to note is these entries are all of them whole numbers. And so, they could be anything that's a whole number. For example, they could be monkeys in different areas of a zoo. One area has 3, one has 8, one has 9, and one has 10. And what's the average? 7.5. Don't round. You were going to round, weren't you? Yes, don't round. The average is neither 7 nor 8. The average is 7.5. Let us make an observation here. The average does not even have to be a possible value of the variable being measured. I know you're all shouting at the screen, going, you can't have 7.5 monkeys. I completely agree. You're right. So what you're learning is the average is not a number of monkeys. It's not a possible number of monkeys. and you must not round it off. The average is 7.5. And so the question that must be at the forefront of your minds is, well, okay, it's not this, it's not this, and it's not this. What is it then? It better be something good, because people calculate it all the time. And indeed, it is a wonderful quantity, the average, and we will go through what it actually does do. Starting with its properties as a smoother. So here's a list, and you can imagine 4 people. The first person has $1, the second person has $2, the third has 3, and the fourth has 4. These are 4 people, and they have differing amounts of money. The average in the easy calculation is $10. And what I want to do now is examine carefully the calculation that led to the average. What was the first step? Well, the first step was to collect everybody's money and put it all in one big pot. You add the whole lot up. And the total pot then contains $10. And the next step is to take that total pot of $10 and split it evenly among the 4 people. And that split gives everybody $2.50. Each person ends up with $2.50. So while previously this person with $4 was quite a bit richer than this person with $1, once you've averaged the money out, then you can imagine everybody has $2.50 and they're all equal. In that sense, the average has smoothed out their fortunes. And it is worth noting that this same operation of smoothing can be done in a different order. So here's an equivalent calculation. Do it in the opposite order. First, tell everybody, take your contribution and you split your contribution 4 ways. And so this person with $1 would split the $1 4 ways and get a quarter, a quarter, a quarter, and a quarter. And so would each of the others split their contributions 4 ways. So the person who was sitting with $1 in front of them now has 4 quarters. And in your next step, you give each person one of these pieces from everyone. So each person gets one of this person's quarters, one of this person's 50 cents, one of this person's 75 cents, and one of this person's dollars. And you add them all up and you have $2.50, which is your average. You've just found it in another way. And once again, everybody ends up with $2.50. So that's an interesting observation, but it's also quite useful when you are trying to calculate what happens to an average when you mess with the numbers on the list. So for example, let's go back to our list, $1, $2, $3, $4 with an average of $2.50, and suppose one of the people strikes it rich. One of the people gets another $100. And no, I'm not going to tell you which one it was. One of the people gets another $100. Then what happens to the average? Well, yes, exactly, you're right. It goes up. Next question. Yep, by how much? Well, let's see. Can we calculate the average? Certainly, if I had told you which person had got the extra $100, you could have actually calculated the average and you'd have got an answer, but you don't really need to do that. All that we need to note is that that total pot of money has increased by $100, and that when the total pot is divided 4 ways, this $100 will get divided 4 ways. And so the change to the average will be that change of $100 divided 4 ways, that's $25. And so the new average is going to be the old average of $2.50 plus your change, which is $25. And so you have $2.50 plus 25, that's $27.50. No algebra needed, just an understanding of what's happening to the total pot of money. And before we move on, it's worth noting what we used and didn't use to answer this question. We did not need to know who was the person who got the extra $100. We did not need to know that this became 101 or this became 103. We just needed to know that the total pot changed by 100. And in fact, we didn't need to know how much money each person had. We really didn't need to know what these different amounts were. What did we use? We used the change and we used the number of entries. And that gave us the change to the average. And to find the new average, we used that and the old average. But we did not actually use details of the list. And so every time you see a calculation, it'll be a great idea if you look to see what did I use, and also make a note of what did I not use. Now, once we've understood this, we can extend this to changing multiple entries in a list. And so here's a situation that I come across from time to time. I've got a class and it's taken an exam, and a couple of students will come back to me saying, no, I didn't like how this problem was graded, or you missed something here, and they ask for the question to be regraded. And so if after that their scores change, then the class average changes. And so here is a question that addresses how much that average will change. I'm starting with 30 students who had an average of 65 on the midterm, and 2 students came to me asking for a regrade. After the regrade, one student's score increased by 10 points. Really? 10 points? Doesn't happen on my exams. After the regrading, one student's score increases by 10 points in somebody else's class, and the other came down by 4 points. That's also pretty tough. You ask for a regrade and your points come down. Well, one person's score went up by 10, the other person's score came down by 4. Surely there's going to be a change to the average. So what happens to the average? Well, we know that what we need to look at is how much did the total change. And the total changed by the plus 10 and a minus 4. So plus 10 minus 4 is a plus 6. That's the change to the total pot of points. And this change gets split evenly among the 30 students. And so the change to the average is 6 divided by 30, and that's 0.2. That's a fifth. And so what is the average in the end? It's your old average, which was 65, to which you add 0.2, and your new average is 65.2. No algebra, just an understanding of this smoothing operation that is the average.